So good afternoon, you guys. My name is Derek. I'm an engineer at Google, and I've been doing the Redfish integration into our data center over the last few years. So this is a talk to talk about some of our experiences and learnings from integrating Redfish into the Google automation stack. So let's get started. We're going to talk about 4 themes today. 2 are kind of related to software development. There's kind of a there's kind of a human aspect to Redfish adoption. So what's it like to scale out to a lot of different developing teams to adopt Redfish, and how to track usage across all the different orgs within a company as we adopt Redfish in the data center. And then there's another track that was very difficult for us about modeling, which is how do we ensure that all our users that are adopting Redfish have the telemetry and models that they require, and how do we standardize on any of the telemetry and the modeling that we depend on. So I'm going to get started with some background on our experience before Redfish and what it was like for us to go from a land before Redfish to a land with Redfish. Prior to Redfish, Google has been using a proprietary management service. It's kind of it's a daemon that runs on the host. It has roughly like an entity component design pattern that models all the hardware and how it's connected, and describes the telemetry as properties on each of the components. So it's got its own kind of logical model of how a system looks like, just like how Redfish has its own model of how the system looks like. And over the last decade, Google automation has depended really heavily on this precise model to model parts of the machine lifecycle. So, for example, for automation detecting any hardware issues, like let's say there's a problem with that DIM0 on the machine, we have collectors that know how to collect this particular model format. We have diagnostic services which know how to parse information in this model format, and then we have repair services which know how to dispatch humans in order to replace and do actions on hardware identified in this data model. So this data model, the abstractions that it provides, permeates the entire automation stack. So, aside from fault detection and repairs, there's lots of other automated services that depend on the same abstraction. So you can imagine there's like firmware management, installation, provisioning, decommissioning. Like there's lots and lots of different clients and users, and they're not all in the same org. These are distributed teams across Google. So the challenge is we tell them, hey, we're getting rid of the old model and we're putting in the Redfish model instead. You run into kind of these 4 main challenges. On the software engineering side, all of these are automated services, and business viability of our data center management depends on all of these remaining automated. So how do we ensure the Redfish consumption can be handled by these automated services? And it's a distributed problem organizationally. So these are all different teams owned by different people with different sets of expertise, and not everybody has the same familiarity with Redfish. So how do we scale out the adoption of Redfish? And then furthermore, there's the modeling challenges, which is everybody's used to the old model. How do we get them to be compatible with the new model? And a lot of the requirements that people have is like, hey, we have a system built on all these assumptions. They're all based on what the legacy system could do, and not what Redfish can do. I'll go into more details about that. So, we're going to start with the client development perspective. What do we have today at Google is we have an imperative C++ library. It's very similar to the DMTF libredfish library, which is a C library. Ours is a C++ library, and we borrowed many of their concepts. So, here's some code example, but basically it gives you a way to imperatively query the entire Redfish tree as if it were one giant JSON document and invoke some callbacks. So it's just a nifty little way of doing code. But we're realizing, an imperative C++ library doesn't really scale when we onboard many cross-organizational teams. So you can imagine everybody will have slightly different code, or maybe they'll write slightly different query functions, or maybe they can't use C++, they have to use like different languages. And with Redfish, there's lots of different places where the same information can live. So if you want to get part information, for example, like maybe is the part information under chassis or is it under drive? Or if you're looking for drives, like drive can be under a whole bunch of different URIs. So it can be kind of challenging for all the different clients to be consistent. So we're realizing, okay, it's all right if one team had to write like imperative style code. It doesn't really scale when we have 20 teams having to write code for roughly the same kinds of queries. So the question we're asking is, how do we simplify the Redfish usage across the company for many independent teams? And we have these additional requirements that fall out of it. If the Redfish usage is distributed, how do we automate the tracking of the resource and property requirements? How do we abstract away the usage of performance features like queries? And how can we provide something higher level, something functional that can be agnostic to the programming language? So, Redfish query parameters, as I mentioned in this slide, like abstracting away the performance features, these query parameters are optional according to the Redfish specification, but to Google they're actually very important because we have very high throughput automation that needs to hit these Redfish services for a lot of information at very high rates. So we need to squeeze out all the performance we can get. So query parameters like expand, select, e-tags for caching, clients need to know how to use these efficiently. And if you have an imperative style language, it becomes very messy to insert these into your code in a very generic and compatible way. So yeah, we kind of have, like, these are the 4 problems that we have. And you can kind of separate them into 2 categories. We have the tactical stuff, which is for one team adopting Redfish, how do you model your requirements? How do you meet your SLOs for your client implementation? And then you have like an organizational track of problems where as you scale up to many teams, how do you track the requirements company-wide? How do you simplify the development? How do you have common platforms and tools to support all the different teams together? So this is our roadmap. This is a kind of a tentative plan on what our company wants to work on in the coming quarters to help solve some of these problems. So our first part of this roadmap will address these 3 particular problems. Specifically, like what our common development framework across Google we plan to look like. So we want to have this common framework so that for our clients we can abstract away all the performance implementation features and normalize some of the modeling discrepancies in the Redfish schema. And then as a byproduct of having a common development framework, can we develop some common tools like performance monitoring and debugging, property tracking, and like how do we track basically those 2, property tracking and performance monitoring. So this is a high-level view of what we're proposing to work on. Is we want to define a high-level Redfish query language. So instead of writing imperative-style code, we would have our clients instead write these query syntaxes. And instead of the clients themselves having to write exactly how to query the Redfish service, we would have a common query engine implementation that all the different clients can use, and that would be what is responsible for sending the queries to and executing the Redfish queries to the Redfish services. And as a byproduct of folks writing queries, they will use the common query engine. So in production, all the high throughput automation, all their requirements can be satisfied by the common query engine. If there's any debuggability requirements that are needed, if there's any debugging that needs to happen, any performance issues that arise in production, then we can create a common set of tools that can plug into the common query engine in order to do debugging. So there's kind of like a live debugging, a manual debugging use case that we were going to meet as well. And finally, we want to take these queries and kind of propose some query to profile tool in order to automate the generation of an interop profile. And we can use these interop profiles that we are automatically generating so that we can, so that these profiles are live, so that these profiles match the queries that are being used in production instead of requiring manual toil to keep in sync. And these are the Redfish profiles that are used in interoperability validation. So, what's in a query? Like the query essentially is two parts. What resources do you care about and what properties do you want? To answer the first part, we are proposing something called RedPath. And to answer the second part, we are proposing just to use the JSON fragments that are currently being used already in the Redfish specification. So a query, this is one way a query could be formatted in a JSON. Maybe you'll name your query, you give it a RedPath. Maybe you'll have more than one RedPath to say these are all the possible processors you might care about. But you would have some list of RedPaths to show what resources you care about, and then all the property paths to indicate what properties you care about. So RedPath, a quick summary of it, it's based loosely on XPath. It's actually by Patrick Boyd from Dell Technologies. And these are some examples that he's provided on, this is like one way that you can return the first chassis instance, or how to get a chassis instance matching a particular SKU, or how to get all the systems, or getting all the chassis that have location info. So it's one way to query for a particular, it's one way to query resources throughout a tree and apply specific filtering constraints. And then the JSON fragments, this is the same RFC as referenced in the Redfish specification. So this is how you can reference sub-properties within a Redfish resource. So the thing we like about this concept is that queries are more portable in code. So if you had 3 services, they all have to use the same Redfish client library in order to share the same code. This is kind of the state we are at today. And where we want to get to is a way for us to have, instead of imperative query code, we move to query strings. So all of our users would supply strings, and there are language-specific engines which they would support. And that way, you can reuse queries across different services, regardless of language, regardless of who is writing the queries. So you can imagine in one situation where we're working with a vendor developing some new hardware, and the vendor writes some diagnostics for error detection. We can easily take the same queries that the vendors write and plumb that into our health automation. So it's easier and more portable, even between environments and languages, to share queries rather than sharing code. So the other problem that we have is usage tracking. So across all the different teams and all the different clients in Google, everybody's going to have different resource requirements, different property requirements. And the challenge that we've kind of run into over the last year is that no one really likes to write interoperability profiles. To clarify what I mean with that is, it's very toilsome to write the interop profile. So not only do you have to write the client code to actually do the queries, you then have to manually write out the interop profile to describe everything that you need. And then as the code evolves, you have to also update the interop profile. And then you have to also manage the deployment of the profiles, pushing it to vendors, making sure the most updated version is running. And there's just a lot of human toil in that process. So we're proposing a mechanism to automatically generate the profiles automatically from the queries. Because if people are interested in the functionality of their software, and they will just maintain the queries to make sure that the systems keep working, can we automate the toil away from maintaining interop profiles so that they also stay up to date? So what we have proposed is you have your query language that says, here are all the resources I care about, here's all the properties I care about. Can we feed that into some tool that generates a very simple interop profile? And our assumption is having any interop profile is better than having no interop profile. Even if it's very basic and very primitive and perhaps very permissive, it's better to have something rather than no interop profile as well. So overall, this is the big picture. As we scale up the number of users, we have all the users writing whatever queries that they require for their service. In production, you have the left half where production will take the queries, feed it into a common query engine, and those will be clients for all the different Redfish services that we have in the Google fleet. And then on the opposite side, we will have, we take these queries and we will feed them into a Redfish profile generator that turns these into Redfish profiles so that offline, outside of production, we can use them for interop validation of the existing fleet, as well as to qualify interoperability with any future machines we would like to integrate into the Google fleet. Question?
Do you have an example of an interrupt profile that you're talking about?
Do I have an example of the interrupt profile that I'm talking about? Not in the slide deck, but if you search for if you just search for the Redfish interoperability profile specification, I actually think the specification is pretty good and providing some examples and providing all the functionalities that the profiles can do. Yeah?
So it seems like the concept of the profile you're using here, I'm going to call it micro or subsystem or whatever profile, or are you talking about, because right now the way the profile spec works is they're complete system Redfish tree, not just some component. It seems like Turing, using the query language, kind of is generating a component profile more than anything.
Yeah, but along the way, like you can still pull out stuff from like let's say you have something that says like get me all the memory. Like you're pulling out, like you can describe the dependency of what you need on the service route because you need the memory collection or the system collection, and then the system part, and then the memory part, and then finally you have a more fleshed out requirement on what you need the leaf memory resource to provide.
It's still a very small profile.
It is, but the goal is like what we want for some of these machines that we're integrating in the future is not whether it can run the entire Google system.
No, I like the idea. I always have. I've been in a minority on that.
Right. But yeah, our goal is really like workflow based. So a lot of our machines, as they get delivered, they don't need full support from day one. We're trying to get incremental support. So, a lot of the times we get asked during scheduling and planning is like, how long will it take for us to be able to bring the machine up in the data center? How long will it take for us to do installs? How long will it take for us to do, when will we be able to do repairability? When will we be able to do provisioning? So having these smaller profiles allows us to do more of a milestone-based planning approach, which is what we would like, which is the granularity that's more useful at Google. So yeah, thanks for these questions, and we're also looking for any other questions you guys might have. So can we standardize on these client interfaces? So does this query language make sense? Would there be anyone else interested in using this? We're developing these tools in the open on our GitHub repo for machine management. You can see the link there. And we also participate actively in the tools task force with DMTF. So you can see us bringing some of these discussions to that forum as well. So before we move on, are there any other questions? Oh, yeah.
At the beginning of your talk, you mentioned that you had a proprietary solution, but then you went to adopt the Redfish, and obviously it's a lot of work. What was the motivation for making the switch?
Well, okay, so the question is, we had a proprietary stack, and then there clearly must be a lot of work to switch to the Redfish stack. What's the motivation for switching? Because we're seeing more and more companies adopt Redfish, especially from like a manufacturing standpoint, it makes sense for Google as well to converge to the same standard. And the longer we stay on our proprietary stack, it means we will need to spend more resources adapting Redfish to fit the proprietary stack. And for us, it's considered technical debt, as if we're trying to stay away from the same standard that the rest of the industry is trending towards. So we're making the bet that Redfish is going to be widely adopted, and we are committing to adopting Redfish by migrating all of our stacks to supporting Redfish as a first-class citizen. All right. So we're going to go to like a part 2. This is more on data modeling. So this goes more into the question that was just asked about what was it like going from the legacy stack to the Redfish stack. So out of those 4 problems, this is the how do we model requirements in Redfish portion of the problem. So over a decade of automation has been developed against the legacy management system and its model. And switching to Redfish means we have to always make these decisions on what do we switch? Do we have to make the legacy API match Redfish? Do we make the Redfish API match the legacy API? Do we have an abstraction layer to make both APIs match? So what I think one of the things that we tried is like, could we make Redfish match the legacy API? And the problem is the legacy API exposes a lot more low-level and debugging information than Redfish does today. So where our proprietary stack usually exposes the pin, we say, like it will expose the GPIO, Redfish prefers to expose a much higher level abstraction. And there's also a lot of custom telemetry that we've developed in-house that we export through our proprietary APIs. None of that really exists in Redfish, obviously, because it's been developed in-house. So this produces some anxiety within some client teams at Google when we tell them, hey, over the next few years, we're trying to align and adopt Redfish across the board. Some of these concerns include speed of upstreaming. They say, hey, it's really easy for us to add new telemetry to the legacy API when everything is custom. If we have to go through standards, is everything going to be slow? So on paper, these teams are afraid of DMTF interactions because it's not in the control of our company. But in practice, over the last few years, we've been working closely with DMTF to doing some upstreaming. We've been pretty happy with the response speed and the interaction we get from the issues and polls. So we're trying to say, like, this is not really a problem. More of the problems should be focused on generalizability, which is if we're the only people who consume information like GPIOs or our own custom kernel sysfs telemetry, why should we switch from legacy to Redfish, or how do we even do this modeling? These are some of the harder questions that we are trying to justify internally. So here are some case studies of our migration. One is NVMe telemetry. We have a lot of repair automation rules based on low-level commands and log pages. So, we weren't able to get this telemetry out of Redfish directly, but we would like to have these raw bits exported so that we can read them ourselves. We had two options. Do we change our legacy services to match the higher level services and migrate all of our clients? Or do we have to upstream low-level properties into Redfish and Swordfish? I don't think we've made progress on this, so I don't think we've just come up with a decision on which way to go forward on. Another one is custom hardware firmware updates. This was an interesting one where a firmware update required setting a GPIO to high in order to disable the write protect on one portion of the storage. So our legacy API had a GPIO that the updater knows to set to high. But in Redfish, how you would do this is you would patch the updatable property to true in the firmware inventory. So what should we do in this case? Do we want to change all users of the legacy APIs to now match the new semantics for updatable? Or do we keep the legacy API and try to push some GPIO emulation into Redfish? And what actually ended up happening in this case is we did both. For time to market reasons, we had to push the GPIO using OEM into our Redfish implementation. And in the background, over the course of 6 months to 1 year, we had to slowly migrate all the users of the legacy API to the more reasonable, higher level property for updatable. So it required a two-pronged approach in order to address this issue. And the third case study has to do with hardware identification, where our hardware ID scheme has to be consistent with the legacy system, because we have databases of decades of hardware telemetry that needs to be backwards compatible. So, the question is, should we make our Redfish servers export Google IDs, or should we migrate all the historical data to use some ID scheme based off of Redfish? The solution we ended up picking was to instead generalize the ID scheme to make it possible to derive the Google IDs using Redfish properties. I'll walk through that generalization in the next slide. But the main concerns we have is if we're the only folks using the scheme, we can't really rely on the properties being available in arbitrary off-the-shelf systems. So right now we're working with vendors to say, hey, we have our particular Google ID scheme. We need these specific Redfish properties. Can you please implement them? And they aren't readily implemented or off the shelf. There are additional asks that we are making. So we're interested in knowing, does anybody else have hardware identification requirements? Is there an opportunity for us to standardize across companies on a common hardware ID scheme? So an overview of what we do is we're basically using the service label property that Redfish provides. Service label is defined to be a silkscreen name or something that's physically identifying the piece of hardware. And we're saying every single piece of hardware in the system can be identified with a sequence of service labels. So the baseboard is the base case where it just doesn't have a service label or doesn't need to have a service label. But everything else would be if you want to say this CPU this is the processor with the service label CPU 0 on the baseboard. So it gets an identifier of just CPU 0. But if you want to refer to this CPU unambiguously, then you would have to find the sequence of service labels to find it. So in this one, it would be the processor with the service label CPU on the riser attached to the cable with service label riser 0. So if you follow all the service labels from the main chassis, you go to the riser 1 service label, then you go to, you see it's on the other end of the cable, and then it's a service label marked CPU. And then you have this processor, unambiguous to this other processor on the system. So this is our hardware identification scheme using silkscreen names to unambiguously find, identify pieces of hardware on the system using Redfish properties. We have this documented in our public GitHub, but we're also interested in knowing what other people are doing to disambiguate hardware in their system. So some other upcoming use cases that we have that we don't really know how to solve, whether it's like pushing new things into the model, storage key management. Google does some special things, like we have our own lifecycle that's split between like a management controller and the host. So we have all these functionalities, and do we want to model some of these operations even though they're not very common across the industry? It's like a Google proprietary key management scheme. So what can we upstream, or do we leave everything special for Google? We have a bunch of low-level protocol requirements. So we use like TCG Opal. We have ATA commands, smart commands, smart logs. Do we just need to go push to have more of these added to the specification? Do we need to push for pass-through? NVMe is kind of the same thing. We have like specific commands and vendor unique commands that we want to push through, and like log page information that we need. Do we need to make sure that these show up? And then all of the other miscellaneous low-level telemetry that we talked about, like fuse states and GPIOs and electrical debugging and telemetry decoding. So some of the stuff we don't really know how it will go into the standard, if it should go in the standard. So in summary, yeah, this is just summarizing everything we went through. There's a software developing front where we want to create some higher level client development tools to simplify cross-organization client adoption of Redfish and to automate more of the Redfish tracking across the organization. And then there's the modeling front, which is our personal struggles with how do we normalize the Redfish telemetry with the legacy model, and how do we get ahead of any of the modeling gaps we need into Redfish. I think the modeling part, we can be a little bit more proactive with reaching out, but if your company has use cases that might be similar to ours, please reach out and maybe we can discuss together on how we can have common models. But for software development, we're really interested in knowing if anybody else would be interested in collaborating on the same tools, or if they have other tools that fulfill the needs that we have. So please get in touch. We have our open library on GitHub, and you can always reach out by email. And yeah, that's it. Thank you. You guys have any questions? Yeah.
So it seems like some of the things you're describing here, it seems like it would make sense to do it to Redfish up to a point and then switch over, like NVMe management commands. It seems like that's something that would be like external.
Right, and I think part of it as well is like, what if we're not sure how much normalization we want to do in Redfish? Like, are we using the NVMe schema to get some telemetry that might be also available through a different protocol? Do we want Redfish to be normalizing multiple protocols, or do we want the normalization to be happening in the Redfish client? I think those are some of the challenges that we're facing, and we don't know, do we want to expose the raw pass-through interface, or do we want to provide higher level abstractions in the Redfish standard? So I agree. I think both are viable options, and we need to bring more use cases up in order to get progress.